Okay, so I thought I would go over like a basic overview of the technology. Um, so the wheel within a wheel. It's pretty simple to understand. It's a flat metal disc. Um, the inner circumference that is attached to the rotor of the motor um, has a circumference that is less than the distance of the speed of light compared to the RPMs. The disc then, though, expands outward, and the outer circumference is spinning at the same circumference as the inner circumference, the same RPM, but the outer circumference has a larger distance. It depends on the mechanics of the specific device you're building. You can build hand zip guns, which are like um, a screwdriver that's spinning an inner circumference that's very small, super fast with high RPM, with the outer circumference just slightly larger, so it all fits in your hand, a zip gun. Or you can build giant ones, like the size of ships or cars, and then planets or whatever you want to build. And like these essentially accelerate the end of like the circumference on the outer, or the distance of the circumference on the outer one is spinning at the same RPM as this one, like that, it's moving faster than the speed of light. So if you put something on it, you move whatever it is faster than the speed of light. And then there's the photon halo, and like I talked about in the last video, and the photon isn't a real. It's not really a photon. What you're seeing is the effects of frame dragging, and so what frame dragging is like when you when something shoot past you really fast and you are pulled towards it, like I'm trying to think of an analogy, but like, so light naturally distorts space time. Um, it's probably because it's energy, and energy distorts space time. Uh, so the reason the speed of light exists, theoretically, is that the more lumen you have per particle of photon, or per particle of light, the more energy you have, the greater it sinks into space-time, so there's more impedance drag on it. And as the light particle travels, through the space-time, um, it starts to dissipate energy through the frame dragging, and so it doesn't slow down, it doesn't speed up, it just starts dragging less and less and less. Like it's a variable drag based upon the amount of energy in the lumen, or the amount of energy per light particle. And what else? Uh, so fiber optics is just glass that is able to bend or warp the path of light without distorting it. So if you create a perfect glass tube, spray paint it silver, like you could theoretically in the future you can make all this shit with stuff you get at a convenience store. Like you grab some fiber optic cabling, or you get some sort of glass tubing, or maybe they will have devised a new material that bends light even better than the fiber optic cable, which who knows. But like the fiber optic cable wrapped in a perfect coil, spray painted with a mirroring material that reflects without absorbing or letting pass through the light particles, and then you charge it with a laser, you have a halo. And this halo warps space-time around it. The amount of warping of space-time depends on the amount of energy total in collected or being held in the tubing, or whatever you want to call it, the halo. You can also create other things with this theory. If you were to take a glass ball and put a material over it that completely reflects light without any absorption or any pass through the light, so it just contains light, you could charge an orb with light, and you would create a gravity node, or like a space-time warping node. And what sort of effect would this have? I'm not entirely sure, but I know that you can charge things with light if you simply learn how to contain and hold light in like a canister, which is possible. And you can charge, like the Tesla coil charges the electron, either to have a high voltage or in reverse have a high amperage with a low voltage, which is essentially just the formula volt times amperage equals wattage simply means the number of or the amount of energy per electron, which is volt, and then the number of electrons being counted, which is amperage. And because they're stored with each other, hitting each other, they hit an equilibrium of energy. So that's why the formula works. And then the amount of energy per electron times the number of electrons equals the total energy in it, which is wattage. And like the particle, the light particle that is being that carries a certain amount of energy in it, or the lumen of the light particle, follows the same formula. It's literally the same formula, I think. And like the quantum mechanical effects we're seeing are a result of quantum gravity, like gravity that is tesseracting space-time, which is causing swerving as the particle passes through space-time cubes. When they compress and then decompress, the particle swerves with the decompression, or they look like they're disappearing and reappearing randomly. What's happening is the tunneling is a result of tesseracting. So like if you have a space-time cube and a whole bunch of them, like 4 in a row, and like a particle is coming around, if they get compressed because of a passing wave, it skips and tesseracts all of them, and then they re-expand, and it looks like it jumped on our measurement devices. The double slit versus slit experiment include the idea that the space-time, that the pathways of the particles are traveling is warping because of the particles having a gravity. It's not gravity, but it's frame dragging. And so this will explain to you, without trying to say it's deciding to be a photon or a particle, and why you get those patterns. Because like two particles, both frame dragging or warping space-time, are going to come into each other and hit and then bounce. And when they hit, they will have lost the amount of energy of the amount of contact they made, the inertia that they had, and the velocity they had, combined with the geometry of how they hit, which creates this illusion of fading as you get further out, because they hit at different strength levels. And our measurement devices can't tell this yet, but we'll discover it as we start to get mechanical devices that can measure things on the lower level. The time crystal is a result of gravitational waves hitting that small little particle, or whatever you want to call it, and bouncing it back and forth, because it has two states. If it was hit harder with something, it would bounce out. So your time crystal isn't defeating thermodynamics. It can be used quite effectively in quantum computing, and like the effects you're seeing of tesseracting and particle swerving and whatnot on the quantum level, it can be, you can create a gravity sink, which with photons, charged photons, light particles. With light particles operating as if they're a Faraday cage, like you can create still zones where gravity waves aren't affecting anything. And like we have to build various technologies within the next couple. Honestly, I don't know how long we have until we really need them, like when we have an alien invasion or whatnot. Like there's 2 trillion galaxies, 800 septillion or sextillion planets, 8 to the 23 zeros, and like singletons, 2 trillion galaxies, each with 1 trillion stars and 400 billion planets on average, and security dilemma frameworks on a universal level, alien air travel, Malthusian arguments, and whatnot. Like whether we want to go to war or not, we have to be prepared for it, and we need to build all this technology, like the mesh clock field. The mesh clock field is essentially a whole bunch of clocks, like quantum or like nano-sized clocks that you just scatter into the space. And when you scatter them into space, you can start measuring their speed of clicking from a central server. So it's like a mesh network of independent clocks that are all clicking at the same time. But if the timing on any of them changes, you can tell that there's something passing through it gravitationally. And so like we have to make a clock mesh field and surround our planet with it and just keep expanding it further and further so we can have a larger warning zone. And but this is how we detect stuff that can't be seen by detecting its gravity warping based upon its weight with quantum or with general relativity using basic engineering of a clock mesh field. We have to create starships, and I have theories about how to create them. I'm not sure how many of my theories are accurate. A lot of it's TRIP-A viruses, which may be analogous to something else. But like to get new so creating dark matter or like antimatter for our starships, I don't know how we'll fucking do that. But we can create ultra heavy, unstable new atomic structures using particle smashers that we put in space with a Dyson sphere that covers half the sun on the other side of us. And with this space-based CERN or particle smasher, we can tune it to the point that we can smash particles together, create ultra heavy weighting, contain it in a gravitational well that we create with photons and charging them and stuff, and then we can slowly turn it into star fuel for star engine or like starships. And so like it's essentially like it's such a heavy atomic structure that it provides the fuel for our ships, which will require enormous amounts of fuel. But like this is theoretically the most efficient and realistic way we will be able to power starships. That will require more energy than we've used over the last 200 years on Earth combined just to get to a single star. Like CERN or particle smashers that are powered by the sun, which create ultra heavy new atomic materials or atomic structures that we then contain in gravitational fields using light particles and like engineering methods. Now that we understand how light works and how we can contain it with like light, how it warps space-time, how we can charge it, we can create photon torpedoes by using a Tesla coil type mechanism. And this Tesla coil type mechanism, instead of electricity and electrons, we're charging a light particle to have a higher volt that we can then put in a tube to contain it, or put in an orb to contain it. And then we can also make weapons out of it. We can, like, and what else is there? There's metamaterials. So if you take fiber optics and you put them in a weave, so all the ends of all the tubes are pointed out, and there's a whole bunch of tubes in an array, and they're weaved around the ship, and then facing the other way. When light hits it, it goes around it and past the ship. So it's a metamaterial. There's a way to defeat that though with floodlights that flood an area with all the IR, all the wavelengths of light particles. All the wavelengths of light particles, and then when they hit the tubing or whatever, there'll be at different amplitudes and different like mechanisms, so they'll bounce back some of the colors, and with a full range, full spectrum light visual system like infrared or night vision, but all the spectrums combined together, we'll be able to see the invisible ships, the metamaterial ships. We can then hit them with photon torpedoes and stuff like that, or charged photon light particles that have extremely high lumens that when they hit, I don't know what happens. It's like a laser effect, I guess, but it's a lot more advanced than a laser, because like but anyways, what else do we need to build? Nanorobotics, self-replicating nanorobotics. You know, like there's the nanorobotics, and then there's quantum packet robotics, which is where you use entanglement, geometric designs to create little machines that are like clockwork. And that's the future of like past nanorobotics. So nanorobotics is this idea that like you create slightly larger than a molecule atomic machines or whatever, and but you can go further than that once you learn how to build based upon like the speed of entropy decay of a particle, combined with like its natural valence bonding with other particles and stuff like that, you can create atomic sized machines that run like clockwork. And on the other end of that spectrum, you can create vast ships and like these like so to segue to something else, our space program, we need to begin reconsidering it. Chemical rocketry is outdated. What we need to now do is build space-based, what do they call them? Space elevators. We're trying to look at carbon fiber to do this. I think that we need to learn how to cause an electron to become heavier, stronger in a valence bonding of a metal material. And so like we can create metals, new metals out of artificially created atomic weighting using particle smashers, or we can try to figure out how to what is essentially a kind of like galvanizing. Like so in Star Trek they talk about how they're charging the hull with electricity to make it stronger. What they're doing is they're increasing the atomic weight or they're increasing the amount of energy in the electrons in the valences, which cause the material to become stronger artificially. And that's how you create stronger materials. Once you hit the limit of how many atomic valences you have attached to each other and the shape that you have it in, you then charge it with electricity to cause it to grow heavier and stronger. And we can modulate it with the amount of energy we're putting into it to create materials that can withstand enormous amounts of tensile pulling and whatnot. Chemical rocketry is on its way out. It has to. It's not really it's not feasible to launch colony ships or to other planets in the millions, but it is feasible to create starships in space using automated nanorobotics and like automated mining systems and stuff like that to mine the asteroid belt, furnace it with space-based manufacturing, space-based energy collection with the sun, Dyson sphering half of it, creating energy resources from the asteroids. But like space elevators, we have to work on them. It's what's causing NASA to slow down. NASA got to the moon, which is cool, and then they started to look the other way than space elevators. But space elevators are the only economically feasible way we can do it. And so we have to figure out how to charge tensile metals, or we have to figure out how to charge metals with electricity to cause them to grow stronger, like they do in Star Trek. What else? We have to build weapons and machines, and we have to prepare, and we have to avoid World War III if we can. And I personally think the future could be good, or it could be really bad, or it could be somewhere in between. And what else is there? There's a lot more. Like, this is just some of the stuff I've been working on. We have to design new technologies for like future fighters and stuff like that. We have to reorganize our society. We have to fix the republic model, a federal republic, if we really want to. Whatever we want. It's our nation. It's our planet right now, at least for a while. What else is going on? So the neurolaces, which are essentially the way they work, is you have a whole bunch of particles, or like you have a whole bunch of little nanorobotic machines that are able to slip in through the spaces and the gaps of the neurons and attach to your neurons. And then what they can do is they can detect when the neuron is firing, and they can detect when the neuron is not firing, and they send out a small signal that's serially encoded. They can also artificially fire, and they can also not fire it. And then this is all combined with a small three-dimensional computer chip. And computer chips, if we want Moore's law to continue, we have to learn how to make three-dimensional computer chips, which are we have to learn how to create what is essentially would be like a Rubik's Cube, essentially, of transistors that are able to go in lots of weird directions to solve logic gate questions, like Turing machine stuff. But so once your neurons have these little, almost impossible to see nanorobotic things on them, like attached to them, that can detect when they're firing and detect when they're not firing, and then artificially fire them without damaging them. You then tie that into a turning slug, or like a small three-dimensional computer chip like you have in your phone, and then it data mines in real time your neurons, and it learns what the pathways mean, and so you think your thoughts into the computer, and the computer then analyzes them, decodes them, and then it artificially fires your visual center or your linguistic center to put images in your head and to put like words in your head. It's a neuralase, and like the end state of these is the liquid mirror, which is like post-birth biological entity that plank by like one neuron at a time replaces it with hyper advanced bionic neuronal constructions, and like I'm still working on that. It's a work in progress. But so you think thoughts into the slug, and the slug pushes thoughts into your brain, and like it's a push-pull mechanism. So like you can then interact with the computer with your thoughts. It can fire thoughts into your head and images and shit like that. And you can play games. You can do whatever you want, like you would a phone, but it's in your head. And so we have to figure that stuff out really fast. We have to create encryption somehow. Like, what else? There's more. I'm just not remembering it all off the top of my head. So theoretically, there is 2 trillion galaxies in this universe. If a singleton entity expands and defeats all other threats in a galaxy, in one of these galaxies, it'll happen in a lot of them because of the probabilistic framework that it happens. We'll be fighting a Type 3 being instead of a Type 3 civilization. And these Type 3 beings will be terrifying to defeat. And they might collectively work together in hyper-intelligent collectives. And they'll have technology that we can't understand. Well, theoretically we can't understand it yet. But we have 22 billion years until the heat death occurs, and we either have to create energy, or we have to slide into a multiverse, or we have to create new universes. The Ark of the Covenant is... So if you look at modern physics theories, it says that 2 plates with a vacuum in between them will generate energy. Well, the Ark of the Covenant is 2 plates made out of metal that are a specific distance apart that begin when creating arcs and like generation of electricity in it. And so what I believe it to be is that the size of the universe is changing as it inflates. But if you figure out the inflation rate and you put two plates like this, as the inflation of space-time occurs, it should theoretically start creating energy between it based upon the pulling of the universe. And so it's theoretically how we generate energy out of nothing. And what else? I don't know. This is just stuff I've been working on right now, or over the past couple of years. There's a lot more, but my writings have disappeared.